let us come to the ray diagram. Okay, the formation of image in case of a convex lens. So we will discuss only the ray diagram related with the convex lens today. Okay, now let us follow this diagram here. Convex lens. This is the principal axis, optical center. AB is the object. Okay, and F1 is the first focal point for the first focus. 2F1 is the twice the first focal point for the first focus. So here, now the object is placed between the optical center and the principal focus. That means the object is placed between the optical center and the first focus or the first focal point. So that means object is between the optical center O and the first focal point F1. So AB is the object here. Now follow the rules. Okay, just now we have discussed that. Follow the 3 rules there. Now let us consider a ray. One ray is there, that means this is the incident ray, which is parallel to the principal axis. After refraction, it passes to the second focus, okay, or the second focal point. So that means a ray of light, incident ray, and straight you draw the ray of light, and that ray has to pass to the second focal point. Then draw another ray here, which passes to the optical center, okay, and when it passes to the optical center, it emerges out without any deviation. Now what we do is that now these are the refracted ray. Now these refracted ray are produced backward. Here also, this is the incident ray, and this is the refracted ray, okay, and now this refracted ray are produced backward here, and this refracted ray are produced backward, and they will meet at one point here, and this point is the image of the object AB, and this image is A dash B dash, okay. And now this image, you can see the size of the object and the size of the image. The size of the image is much more bigger, much more larger. So therefore, the image, now what are the characteristics of the image is that the image is magnified image, larger image. Second one is virtual image. Okay, why the image is virtual image? Because the refracted ray, they are not actually intersecting. They do not intersect actually. They are intersecting when this refracted ray are produced backward. So therefore the image is virtual. Okay, and other one is erect image is forming. Erect image means upright image is forming. So the nature of the image is virtual, erect, and magnified image are formed. Okay, and this type of, and the uses, the application of this lens, it is used as a magnifying glass and in a simple microscope. These are used to make a magnifying glass, because the erect image, magnified images are formed as well as the virtual images are formed. So the application of this lens is, it is used as a magnifying glass as well as to make a simple microscope. Okay, so when the image is between the optical center and the first focal point, the image will be just beyond the first focal point. Okay, so this is the first characteristics of the convex lens. The second one is there. Now the object is at the first focal point, that means at F1. Object is at F1 here. So now AB is the object here. So here follow the same rules here. A ray of light parallel to the principal axis, after refraction it passes to the second focal point. Then again another ray, a ray of light passes to the optical center without any deviation, it emerges out from the lens. So what happens is that now these refracted rays are not intersecting, okay, though the image is forming, but the image is formed at infinity. That means at a very far away, at a very long distance, the image is formed. So the nature of the image is at infinity. The image is formed at infinity, real image is formed, inverted image is formed and magnified. Okay, so real, inverted and magnified images are formed when the object is kept at first focal point in case of a convex lens. And the application of this lens, these are used as a searchlight and a spotlight. These are used in a searchlight and a spotlight, because they produce a parallel beam of light in which the magnified image okay, and the image can be seen at infinity, a very long distance you can see the image, okay, and the magnified image can be formed. So therefore this type of lens, that means when the object is placed at the first focal point, the magnified images are formed, and the application of this lens is used in the to make the searchlight and the spotlight. Third one. Now the object is between the first focal point and twice the first focal point here. That means 2 f1, between f1 and 2 f1. So the same principle will follow here. A ray of light parallel to the principal axis, after refraction passes to the second focal point. Then again another ray of light passes to the optical center, and without any deviation it emerges out to the optical center. From the lens. And therefore the image is formed beyond twice the second focal point. The image is formed beyond the second focal point. That means, and this image, the image is bigger. The size of the image is bigger than the size of the object. Inverted images are formed and magnified images are formed and real. So therefore the character of the image is real, inverted and magnified images are formed. Okay, so when we and the uses, the application of this image of this lens, they are used in making of films, in a projector, in a slide projector, these are used. So when we see this, all the convex lens, they are forming the real image here. Only in one case, the convex lens is forming virtual image. That means the virtual images are formed when the object is placed between the optical center and the first focal point. Otherwise, the images are always real, which can be, and real image, you know that the image which are formed by the actual intersection of the reflective or the refracted ray, we call it as a real image. Okay, and the virtual images are formed without the actual intersection of the reflected or refracted ray. So the similarly, same case is here. The refracted ray they are not actually intersecting, but they will intersect when they are produced backward. So that is why in this case the virtual images are